Alright, sorry about the delay, everyone was just getting the daily activity up. But with that, so today, oops, that is not the, one sec, not notes for today. So today, we're going to pick up software life cycles. From there, we're going to start on inheritance. I suspect we won't finish. I will do the best I can to finish. Let me make sure that my Discord is muted here. Um, so again, we'll talk more about the exam um, tomorrow. I will do the best I can to write up some version of a study guide. There won't be a practice exam. Just letting you know that now. Don't expect one. Hang on, I'm making sure that. There we go. Do you have tenure? I am not tenure track. No. I'm not research oriented. So from there, reminders, exam Friday. Currently, it's going to be available noon to midnight. That is 12 p.m. to 11:59 a.m. I don't have a duration for the exam yet. It could be anywhere from 1 hour to 1 hour 30. It depends on the duration. I'm still working out that detail. I haven't finished writing the exam yet, so therefore I don't have the duration yet. But expect to budget that amount of time. Probably closer to an hour than 2 hours. From there, let's just jump right back in to what we started talking about last time with software development models. So last time, we started talking about using the metaphor of bridge building, the idea that we want to learn from failures, and part of learning from failures is improving our process. Now, this is this leads to a kind of overarching process of thinking about software, and kind of the traditional model is often called the waterfall, and it may look a little something like this. And I should note that generally speaking, so traditional, aka waterfall, is kind of dead. This competes with something called agile. However, all of the fields that I'm going to discuss, or all of the parts of the waterfall model still feature in agile. It's just that in agile, rather than doing one large monolithic process, you break it up into repetitive cycles. So I'll try to distinguish those as I go. But the first is to identify the phases of the waterfall model. The idea of going from the point of where you start, when you decide to build software to solve a problem, until the point where you deploy and then maintain that software. So from that, we start with the requirements or the specification phase. This is the phase where you decide what problem is the software solving and what specific features will this software have to solve that problem. From there, you design a system. You design how the system's going to be structured, what objects, all the way from what architecture you're going to use at a high level to at a low level, what objects exist, what methods exist, what fields exist. From there, you go into coding and implementation. I should note that testing very, very much is part of this phase. This is not something where you do the testing after. So you start coding the individual components of the system. You then integrate those components, doing testing as you integrate, making sure the components work together. This is important because there's been historical examples. So one example is the Mars Climate Orbiter. The Mars Climate Orbiter was a satellite designed to monitor the weather of the Martian atmosphere. So it was launched from Earth to travel and to orbit Mars, much like our own weather satellites. However, the when you're approaching the Martian atmosphere, the satellite had to make several maneuvers to enter the right path to orbit. However, the system that calculated how much thrust I need did not work with the system generating the thrust. And the reason for that was because the system determining, hey, I need X thrust, assumed that X was in Newton seconds of force. Whereas the system that actually applied the thrust assumed the number, or sorry, the system calculated the number in pound seconds. The system applying the thrust assumed that number was Newton seconds, or vice versa. I can't remember which. Point being, one system used metric, the other system used English units, aka freedom units, which is very tongue in cheek. Don't take that seriously. But because the two systems were not integrated properly, because they weren't on the same units, the Mars Climate Orbiter, which you can Google, was lost in the Martian atmosphere. That's what we mean by integration. Bringing the disparate coded systems together to make sure they work together. Finally, you release the software, but you're not done. You're not done at this point. From there, you need to enter the maintenance cycle. And we'll talk about why the maintenance cycle is not a tiny thing. So, again, using that same analogy, software is like construction. The difference between the two is that software is more complicated. You know, in construction, you design what the system's going to be, what features the building needs to have, how many rooms it has, how many windows, etc. That's the requirements phase, getting who wants the building built to give you these information. You design the building and then you construct the building. The difference between software and construction is that very few buildings have no redundancies at all. Which is to say that there's very few buildings that if you remove one brick, the entire building is going to collapse. If you remove one class from a program, from a project, chances are that whole project stops working because one of the systems will stop working. That's something to keep in mind. Now, from these phases, I just want to get, and I want everyone to answer. I only have 24 viewers at the moment, which is a bit lower than I would like, but nonetheless, I want you to type, which of these phases do you think is the most expensive? Which of these phases is the most expensive? Takes the most time, takes the most resources, takes the most programmer time. Seeing a couple people say maintenance. Integration, okay. There's an integration in there. Looks like a lot of you did the reading. It is actually maintenance. This is far and away the most expensive part of the system, is maintenance. And the reason for this we'll get into, but generally the relative cost per phase, about 2/3 of a system's cost, is maintenance. And you may think, well, how is that true? Remember what we talked about yesterday with the Department of Defense? How 50% of the projects just couldn't be used. Please no language in chat, thank you. This is a college course. Maintenance encompasses all changes made to a program after release, and how like 30% of DoD programs had to be dramatically changed to be used, and 50% just couldn't be used. It's gotten better, but that is still a serious problem. So let's go through these phases one at a time, and let's talk about what they entail. The first step is requirements, and a requirement is a statement of what the system should do, or what qualities it should have, from the point of view of the customer or client. It is not from the perspective of the developer. This is not saying how a problem is solved. This is simply saying, what is the problem? What does the system need to do? These should be clear, unambiguous statements of what the system does, and they must be consistent, complete, feasible, and this is a big one, testable. For every requirement, for every statement of what the system can do, I need to be able to open up the program, run it, and perform that task. And it either passes or fails the requirement. It either has the feature or it doesn't. It either meets some constraint or limitation or it doesn't. This does not describe how things are implemented. When I give you the homework, I have not given you requirements documents. I have given you design documents. They are very different. I am not asking you to accomplish something. I'm telling you how to accomplish it in the homework. That is not a requirements document at that point. There are kind of two types of requirements and then a third thing called constraints, which isn't really a requirement, and we'll get into why. The first is a functional requirement. It states, this is what the system does. The second is the non-functional. Now, non-functional requirements are tied to functional requirements. Here's what I mean by this. Let's say you are making a course registration system. There may be a requirement that says a student will log in to the system. That is a functional requirement. It will then say something like, that login should take less than 5 seconds. That login should work successfully 98% of the time. Some things like that. Those are non-functional requirements. Those are qualities to what the functional requirement needs to adhere to. Whether that is efficiency, which is a common one, reliability, and then usability. So, for example, the student should be able to learn how to use the system, how to log in proficiently in under 5 seconds. It should be that obvious. That is a non-functional requirement. With an emphasis on requirements are what the system does. Constraints are limitation on how the system is designed. For example, let me real quick, I'm going to shrink this text just to make sure it all appears on the screen correctly. There we go. For example, if a user says the system must be implemented in Java, that is not a requirement. That is a design choice. The customer is placing that design choice on you, but that therefore isn't a requirement because it's not something that you are suggesting. It's not that's not the reasons requirement. It is not a requirement because it is not about what the system does. It is about how the system is implemented. So constraints are not requirements. They get to how a system is built. Whereas requirements have to do with what the system does. Are there any questions about this so far? So again, generally, functional requirements describe what a system does. Non-functional describes how is not a right word. I'll say to what quality. To what quality it gets done. Whether that quality be efficiency, usability, reliability, etc. Each non-functional requirement is tied to a functional requirement. Now, one functional requirement may have many non-functional requirements. But a non-functional requirement says, this functional requirement performs with this quality. Again, when we're talking about putting limits on how the system is designed, such as your security needs to use NetBadge. That's actually a design constraint because that gets into telling how to manage security. That's not a requirement, that is a constraint. And there is a difference between the two. So from there, again, non-functional versus constraint. Constraint. Client express design requirement. Not the same as a specification requirement. So, from there, let's say that in UVA SIS, we say student enters a list of courses they want to take. SIS produces 5 possible schedules. Let's say this is the requirement. Efficiency, task completed within 20 seconds. Usability, easy to use in 10 minutes of training or experience or something. Security, students must log in with UVA Net Badge. This is a constraint because we are saying how the security should be implemented. If I were to say the transmission needs to be encrypted, then that would be a non-functional requirement. If I say how it needs to be encrypted, then it's now a constraint. So, with that, we're going to do some yes or no questions. Is this a requirement statement? Yes or no? Is this a requirement system? Getting a lot of yeses. It is indeed. Okay, so now we got the yes or no out. I'm going to add a question. Is this functional or non-functional? Functional, you can just type F or N. F for functional, N for non-functional. Or you could type out functional, non-functional. It doesn't bother me. But which is this? Functional or non-functional? This is a functional requirement because it's saying what the system should do. The software will allow the user to enter and edit document information saved by the system. This is a functional requirement. So remember, functional means what the system does. Non-functional means to what quality. Understand also that non-functional does not mean optional. Sometimes people will think that, I find. Functional and non-functional are both required. An example of this, let's, well, it's kind of covered later, so we'll just go to that. Next one. Is this a requirement statement? Is this a requirements statement? Yes or no? Okay, getting mostly. This is, in fact, a requirement statement. But this is not a functional requirement. This is a non-functional requirement. Because we are describing to what quality the query operations will be performed. In this case, less than 5 seconds. So this is a non-functional requirement. The system will be written in Java and make use of the Who GUI interface library. This is a particular type of graphical user interface. Let me do my thing. Is this a requirement? Is this a requirement? So we're a bit more split on. Remember, a constraint is not a requirement statement. A constraint is a limitation on design. It is not a requirement. This is a constraint. This is a constraint saying that the system must be designed using Java and this particular library. So this is not a requirement statement, but it is a constraint. Is this a requirement statement? The connection manager in the system will encapsulate all data related to network connections and handle the cancel operation. Is this a requirement? In this case, this may seem a bit hard to read. This is describing from a design level what each class is responsible for. So this is a design statement. This is not a requirement. Because again, it speaks to how the system is designed. So from there, we're actually going to, I'm just going to put up a list. I have a notepad file here. And I want you all to, first let me resize this. I want you all to work with each other and feel free to jump into Discord. I'm going to give you, we're going to do kind of 2 smaller breaks today. I'm going to give you 4 minutes to go through this list and tell me whether something is F, functional requirement, NF, non-functional, C, constraint, or none of the above. Remember that requirement should be clear, consistent, complete, feasible, and testable. Let's give you until 1:29 p.m. Hop in the Discord or just work by yourself. It's your choice. But see if you can deduce which these are. All right, let's jump right back into it. So, from there, let's work through these. First, the system will run on the client Windows PC, on the client window PCs. Is this functional, non-functional, or is this a constraint? Functional, non-functional, or constraint? Seeing a lot of people put constraint, and it's reasonable to think it's constraint, but this is actually functional. Because saying a system runs on a Windows machine does not actually constrain the design. You don't have to design the system a certain way so that it runs on Windows. It's not the same as writing something in Java as to say it runs on Windows. Saying that something needs to run on a particular platform is actually a functional requirement. And this is clear. Client has certain Windows PCs, it needs to run on that. It is consistent, doesn't contradict with any of the other requirements. It is complete, it clearly states the entire need the system needs to run on the client window PCs. It is feasible, certainly applications can be written to run on that, and it is testable. It is not saying the system needs to be implemented in a certain way. The system simply needs to be designed, the system needs to be able to run on a Windows machine. That doesn't speak to how it is designed. So while this seems like a constraint, this is very, very much a functional requirement. The system shall display the current number of open tickets on the main screen. Is this a functional, non-functional, or none of the above? This is also a functional requirement. It's saying what the system should do. This is what the system needs to do. I will say that it is a bit ambiguous because it doesn't say where, what specifically should display. It says the number of, the current number of open tickets. Later we'll see how we have different kinds of tickets, etc. What specifically should display. Now this is added to down here. I would still call this a functional requirement, but the key is it's a little bit ambiguous, especially when it comes to saying where on the main screen. Okay? The number of open tickets indicator should always be up to date. Functional or non-functional. Or constraint, or none of the above. Getting a lot of non-functionals, which I would agree with. Again, I could probably nitpick this a little bit and say, how do you define up to date? Because the simple reality is the way time works, it can't be completely up to date. Information has to travel and has to be processed. That takes time. So within what fraction of time does it need to be up to date? Does it need to auto-refresh? It's a little bit ambiguous, but I still think this is certainly testable, where you open up the interface on two computers. One opens up a ticket over here, and we see if it updates on another system. That could be a useful test. So, certainly not. If it is a requirement, it's non-functional. Again, just maybe a little bit ambiguous, but that's nitpicking a lot. Number of open tickets indicator should have a black background and a green font. Here, hang on. I want to... Functional, non-functional, or constraint. Or none of the above. So I'm seeing a bunch of people say constraint, and I don't agree it's a constraint. Because with a constraint, we're talking about how the system is designed. That doesn't mean that a user can still want an interface to look a certain way, and that be something that is implemented in a bunch of different ways. They're not making any statement of how the system is implemented. They are saying, I want it to be this color. It would be like going to a car manufacturer. There's a difference between saying, I want a blue car, and I want you to spray paint the car in this way. So this is actually a functional requirement if it is one. Because we're saying how something should appear. We're saying what the system should display information as. So this is really more functional than anything else. Number of open tickets indicators should allow for 4 digits. Functional, non-functional, or constraint. Again, when we're talking, notice that there's been a theme here. When we're talking about how something is displayed, we're actually talking a functional requirement because we're talking about the interface displaying something. The interface performing some action to display information. And so this is a functional requirement. The user should be able to increase or decrease the size of the open ticket indicator font. I want to actually compare the next two. This one is ambiguous. Increase to what? Decrease to what? Can I make the font size 0? Can I make the font size 100? This requirement is arguably connected to this one. But really, we're talking about the system shall allow the user to select 10, 20, 14, 18. If anything, if these were the same requirements linked together, I would say this is functional. But otherwise, I would say this is ambiguous. It's still testable. Still very testable. We could either increase the size or decrease. But in this case, we're talking about really a functional operation. And actually, most of these were functional because this one is certainly functional. Very much so. All right. Moving on, we're going to pick up the pace with this part so that way we can move on to inheritance and have plenty of time for that. Once we're done with the requirements, we move on to design. The idea is we design how the system's integrated. You might see things like UML. UML, by the way, covered in the reading broadly as a way we can describe the fields and actions of a class in documentation, separate from the code. So again, requirements versus design. Requirements is user-facing. You will present, at the end of requirements, you typically present a document to the user saying, this is what the system will do. Design gets into how it's implemented. The user does not care how this is coded. They don't. They care about what the system does. So that's the line between the two. Implementation, this is the part about writing code and doing unit testing. This is not unit testing is not separate. You do both. Whereas integration is about combining disparate parts of the system, which we've already talked about when that can fail in the Mars Climate Orbiter. The last step is maintenance, and code will spend most of its life in maintenance. And a lot of maintenance has nothing to do with fixing bugs. It may have something to do with, for example, releasing your code to a wider audience, updating your code for new systems, new hardware, new software needs. Good software is maintained for a long time because it's actually better to produce new software than not. And so, when you look at maintenance, only about 20% is corrective. That is fixing defects, fixing bugs after release. 60% is perfective, that is adding new features or enhancing existing features. And about 20% is adaptive, making it work in a changing environment. Maintenance is still the most expensive phase, even if the code is released without defects. And I want you to understand broadly how large this maintenance phase can be. In 2014, in December of 2014, Heathrow Airport had to shut down for about 2 hours. Tons of flights had to be diverted. Flights were obviously delayed. Some were canceled. The reason was because their air traffic control software system failed. It crashed. It crashed because of a bug in one line of code in 4 million lines of code. Okay, so we're already talking a much bigger system than any of us, myself included, have written. 4 million lines of code. One line of code had a bug. That bug had been in place since 1969. That's right, the software, which is still there, is still being used, had been in place since 1969. It was written in a language called Jovial. Anyone here ever program in Jovial before? Any Jovial fans out there? You can't even get a Jovial compiler. It was a so it's hard to, because even like, this is ever since, I mean, even the 80s, the norm is if you make a programming language, you make the compiler available to the public. You don't charge for the compiler. About the only language I know of that still does that is MATLAB. But that was, at the time, I mean, this is, again, the late 60s, early 70s. Yeah, it was normal to charge for the compiler. Charge, I mean, literally hundreds of thousands of dollars for it. So Jovial was proprietary. It wasn't like Java where you just download it. 1969 to 2014, this bug never occurs. Never happens. At all. 2014, it brings Heathrow Airport to its knees. Costs thousands upon thousands upon thousands of dollars in damage. All because of one line of code. So your software can last a very long time. The maintenance of that is making sure that it works on new hardware as it comes out. That is adaptive. Adding new features, that is perfective. Fixing that bug that crashed the airport in 2014, that is corrective. Understand, too, what if there's a fault in the requirements? Here's what I mean by a fault in the requirements. You, as a developer, when getting the requirements from the customer, that is finding out from the customer how they want the software to be built, and it is not as simple as saying, what do you want? You'll do a lot. If you take 3240, you'll do a lot of exercises in this. We don't, unfortunately, have time to really delve too deep into it in this class. But it is difficult to get requirements effectively and correctly from the user. If you make a mistake in that phase, if you find out that the user was incorrect about a requirement, if you don't fix it in requirements, it costs 4 times as much in terms of time, energy, person hours of work, whatever, in design. If you find that fault in implementation, 10 times as much. Integration, 30 to 52 times as much. 20 to 368 times as expensive in maintenance. And this has to do with a term, the fruit of the poison tree. It is a legal term. And legally, for example, let's say that someone performs an illegal search on a suspect without a warrant. If that search turns up evidence to tell them to go search somewhere else, they go and search somewhere else and they find deeply, deeply incriminating evidence, evidence that would absolutely convict the person, it is not admissible in court. Because the reason they knew to look there was because the first search was illegal. So that's like a poison root that springs into a tree that bears poison fruit. If you have the wrong requirement at the beginning of the process, you will design the system incorrectly. That will lead you to implement it incorrectly. That will lead you to integrate incorrectly. And as a result, this design ends up needing to be redone, which means this implementation needs to be redone, which means this integration needs to be redone. The key is identify errors as early as possible. Now, last thing I'm going to do is, oh, my whiteboard camera's not working. That is, oh, well, it's not plugged in, that's why. I can fix that. There we go. And there's a knot. Sorry. And there's another knot. Okay. The last thing I'll talk about is just briefly agile. The idea often of the waterfall is that you think of the system as just a series of... Why is this not balancing? Not really sure why. I know it's kind of cockeyed. There we go. We often call this the waterfall because the idea is we start up here at requirements, then we go down to design, and the idea is the information of each stage falls to the stage below it. So here we have implementation. In the traditional waterfall model at this point, and I should note this is really outdated, would do testing after that, which is just, you don't actually do that. But then release, and then maintenance. This is the traditional waterfall model. I mean, right out of the gate, you can already see a problem. You have to go from testing to implementation, right? Because if you find a bug, you have to re-implement it. But the reason it's drawn this way is if you think about a waterfall, it's very easy to go down. And it's very hard to go back up. It takes a lot more energy to go up than down. Down, you just follow the flow. And so this is why, in this model, going back up is problematic. Now, right out of the gate, this should reveal the main problem with the waterfall model. And that is that if the requirements change, the whole system has to be effectively redeveloped. And here's the thing. These will always change. The requirements will always change. It's just a reality. The needs of your customer will change. It won't even be that, oh, we forgot we wanted this, although that will occur. Or, oh, we thought we wanted it this way, but it wasn't. That will occur. But the big issue is just what your customer needs will change. They will have features a year from now that they're not even using. They have no use for at present. So this is where we talk about agile. And the idea of agile is that you have a series of features, and it's like a spike. The reason it's called the spike, if you've ever had a to-do list that you write on sticky notes, a common technique is to actually impale them on a spike. And the idea is whenever you have free time, you just take something off the spike and work on it. You give a bunch of features and put it on the spike. These are all the features the user wants. But you don't release the system when all the features are done. That's not when you do it. Rather, you do a sprint where some selection of features is added into a sprint. And in this sprint, you are going to implement these features and then integrate them into the product. And at the end of the sprint, you release. And this sprint is typically something like 2-week intervals, or maybe a month. The point is, it's not years. The advantage of this is that you quickly get features in front of the user such that if they don't like them, they can suggest changes and those get added to the spike. Now, does this mean some features never get implemented? Yeah, it can actually mean that. Some features that you want may not get implemented. Typically, the customer will have a priority. These are the things we really, really have to have. But the idea is you continuously iterate, and the customer is given small, rather than going from I have no software to, yay, now I have software, the customer goes from, okay, I have software that does some of what I need. Okay, I have software that does a little bit more. Okay, a little bit more. A little bit more. And their satisfaction with the software grows over time. This model is called agile. And I just want you to understand that's what that means. Often agile, we start with something called the MVP. It is not the most valuable player. It is not most or valuable. Does anyone know what MVP stands for? Anyone know what MVP stands for? Stands for minimum viable product. Minimum viable product. By the way, all this stuff on Agile is not on the exam. But it's one of those things that I think it's worth knowing, because you'll hear the term Agile and it'll be like, oh, it means programming faster. No, it very specifically means programming over short, rapid cycles to continuously build on a system and add features over time, rather than going from I have no software to I have the completed software. And that Agile approach is generally more successful. All right. Any last questions on this before we move on to coding stuff? Because everyone loves coding stuff. And while we're doing that, I'm going to go ahead and pull Eclipse up. Go ahead and make my new project for the day. Oh, 624 inheritance. All right. What's the difference between implementation and integration? Implementation is building the system, writing the code for it. Integration is combining separate, disparate parts of the system. Are there any books you recommend to learn more about the software development process? I think any modern software engineering textbook that you can find on the cheap would be not bad. I know books about specific topics, so like if you're talking about specifically design, Gang of Four is a good book, because it talks about design patterns, how you can use certain patterns in your code to make the system easier to maintain. Mythical Man Month is good for understanding the overarching challenges that are present in the system. There's no one thing I would say like this is the book you have to read. Clean. I think there's a book called Clean Code, I think is the name of it, or the Clean Programmer. I think it's Clean Code. That one's not bad, but in terms of the overarching process, any textbook I think would suffice. Certainly the reading I give you is designed to give you what you need to know for this course. You can also take 3240. That's something I'd recommend as well. Anyway. So, let's actually start before we jump into code. Well, actually, now let's go ahead and jump right into code, because I'm sure people are aching for that. Let's consider a class right triangle. Let's say I am writing a class called right triangle. Like any triangle, this is going to have three sides. Double side A, side B, and side C. By the way, this defines three variables, all of type double. So that's pretty convenient. I'm going to say that I need a function for perimeter. Perimeter is pretty simple. Public double perimeter is return side A plus side B plus side C. By the way, real quick, just side C is hypotenuse. That is the longest side of the right triangle. I'm probably spelling that wrong. What does it say? Okay, I don't... Hypotenuse. Sure, we'll say that's close enough. Anyway. From there, I'm actually going to define a constructor, public right triangle, takes in double side A and side B. I'm not going to take in side C because I'm going to calculate that. I'm going to say that this dot side A equals side A. This dot side B equals side B. And this dot side C equals math dot square root side A times side A plus side B times side B. Right, pretty straightforward. Finally, public double area is return 0.5 times side A times side B. Mathematically, pretty straightforward. Let's do a similar but different class. New class, equilateral triangle. So I'm going to take very similar code, and so much so that I'm actually going to do some copy pasting here. It's also going to have private double side A, side B, side C, but I actually only need to take in one side for an equilateral because all three sides are equal. So I just simply say this dot side A is length, and side length. The area, instead of being 0.5 times side A, it is, and I need to just remind myself of this real quick, area of equilateral triangle is math dot square root 3 divided by 4 times side, let's do side A times side A, or side A squared. From there, let's add one more function. Let's add a toString function. Public string toString, and I'm just going to say return triangle with sides plus side A plus comma side B and side C. And similarly, I'm going to have the same toString function for equilateral triangle. Right, so I've defined two triangle classes to model different kinds of triangles. Right triangles and equilateral. Right triangles being triangles with a right angle, equilateral being all three sides of the same. I have 9 viewers right now. Did something happen? That's strange. Oh, 25 now. That was weird. Okay. Anyway. Any questions about this code? It said 9 for a second. I'm like, there's hopefully more than 9 people watching. Anyway, any questions about this code? Right, just 2 triangles, straightforward enough. Notice that of effectively what I've done here, though, is I've implemented 2 very similar things. Now, the constructor for these are different. Equilateral triangle only takes in one side. Right triangle takes in 2. The area calculation is different. But perimeter and toString are identical, right? And this is kind of wasteful. What I can visualize is that I'm going to have some kind of hierarchy. And that hierarchy is going to say, I have a broad way to define triangles. Because all triangles are going to calculate perimeter the same way. All triangles are going to have the same 3 sides. However, each triangle subtype can calculate area in its own way. Each triangle subtype can describe how it is built. So let's put a dog here. We will come back to this in a second. I just need to look at something. And from there, let's talk a little bit about what do we mean by inheritance, and specifically this term polymorphism. You will get asked at some point, what does polymorphism mean? Hopefully this lecture will help you answer that. So, the idea of inheritance, we've talked about how there's this object class, right? We have equals object O, we have toString, we have hash code, and we can also do typecasting. We can cast an object to a specific type in this way, right? This actually illustrates the basis of how inheritance is done. The idea of inheritance is that we have, let's say, some central starting point object. And from there we have a subclassification, animal, and then a subclassification, mammal. From there we could have feline, which sparks two different versions, tiger and house cat. They have the same hierarchy until you get down to the last level, or a separate hierarchy for canine, which includes dogs. Something akin to the animal kingdom. With inheritance, we want to express things as an is a relationship. So that is to say, one thing is another. For example, a right triangle is a triangle. A house cat is a feline. Will is a bald guy. That last one, probably not a great example. But so, I want to give some definitional terms here. A subclass extends a superclass. What we mean by that is if cat is a subclass of feline, that means cat is a feline. Forgive me, I'm going to sneeze. 1 sec. Sorry, I don't like the sound of sneezes. I doubt other people do, so I muted myself there. Anyway, a cat is a feline. That means cat is the subclass, feline is the superclass. So if X is a superclass of Y, then Y is AX. I want to be clear, this is a one-directional relationship. For instance, a square is a quadrilateral. A quadrilateral might be a square, but it is not necessarily a square. In that case, quadrilateral would be the superclass, square the subclass. Square is a quadrilateral. It is, however, transitive. So if I said a square is a parallelogram, and a parallelogram is a quadrilateral, then a square is a quadrilateral. So if A is B and B is C, then A is also C. Any questions about these definitional terms? Because first we need to understand the definitions before we'll understand how objects interact in these hierarchies. So let's take a practical example of where we might want to use something like inheritance structures. Let's say that we had this class called vehicle. And this vehicle defines, say, a number of wheels on a vehicle, defines a color, defines some amount of fuel, defines a current speed it is traveling. This vehicle may have functions like start, which turns the vehicle on, accelerate, which increases the speed, and brake, which decreases the speed. All vehicles in this hierarchy have, and that includes these four vehicles down here, have these features. But from there, I can add specific features for what I need. For example, I can break up this hierarchy into a set of transportation vehicles, that is vehicles for the purpose of shipping goods or moving goods, versus passenger vehicles, vehicles for the express purpose of moving people. And these two fields need different things, need different features. For example, I care about the number of passengers I can seat in a passenger vehicle. I may not care about that in a transport vehicle. Rather, with a transport vehicle, I'm more interested in the load capacity and maybe the number of doors. Now, could I design a system where a passenger vehicle also cares about number of doors? Sure. But for now, let's just go with the diagram as it is. The idea here is that both of these are vehicles. Further, passenger vehicles has two different subclasses, car and bike for motorbike. These each have a set number of seats. Now notice, car has a number of doors, but motorbikes don't have doors. And so motorbike does not have that feature. It does, however, a feature called saddle height. So these attributes are added such that every vehicle, this entire hierarchy, has a number of wheels, a color of fuel, and a speed. For only passenger vehicles have passenger seats. So car has passenger seat, bike has passenger seat. Truck and van do not have those features. Similarly, in addition to adding fields at each level, we can add methods. For example, I can say that I need a method called load van or load container inside my transport vehicles for each type. I load vans, I load containers. This means that trucks do not have a load van function, and vans don't have a load container, but all vans have load van, all trucks have load container. Similarly, I can override methods. For example, the way that I would start a car, a truck, a van is all largely the same. But you start a motorbike often differently. So that might change the start function. That is to say, I override it to say, instead of, and let me change the color of this so it's easier to see. Instead of starting the same way all the other vehicles start, I'm overriding, I'm ignoring what my parent class says to do for start. Motorbikes start differently. Are there any questions about this diagram or what it means? The idea here is I'm defining a hierarchy. All right. So now, let's look at inheritance versus composition. Just to clarify the difference, because we've already said inheritance is a relationship. I want to clarify most of what we've done so far with classes, actually almost all of what we've done with classes, is has a, or composition. For example, the class photo library has a list of photos. It has a ID. Photograph has a file name, has a caption. That is not a hierarchy. That is a composition relationship. Hierarchy very specifically is a. So a Jeep is a car. A car is a vehicle. So if I were writing Java classes for Jeep, I would say, for example, public class Jeep extends car. The subclass extends the superclass. Passenger vehicle extends vehicle. Car extends passenger vehicle. Whereas a car has a engine and has tires. That means the car has fields for engine and tires, but this is not a hierarchy. An engine is not a car. Tires are not a car. Does everyone understand the difference between inheritance and composition before we move on? From there, we have features for a substitutability principle, by which I mean I can treat any subtype as the parent type. I can't do the opposite, but I can treat any subtype like the parent type. So any instance of a subclass also is a superclass. It inherits the states and behaviors of the superclass. And so therefore, if Jeep extends car, then I can say car C equals new Jeep. An example of this that we have talked about before is array list is a list. And linked list is a list. And hash map is a map. And tree map is a map. And so, when writing code, I'm allowed to do things like, let me make a new file here. new class temp. I'm allowed to do things like public static void main list string words equal new array list string. I need to import both libraries, but because a array list is a list, I can treat, oh, sorry, that was covered up. I can treat array list objects as though they were lists. Similarly, I can do list integer numbers equals new array list integer. Now, you may be thinking, why would I want to do that? We'll get to the why later. But I just first want you to accept that this works. That I can change this to a linked list. And this code still compiles. I have to import the library. But because array lists are lists and linked lists are lists, I cannot do the following. I cannot say array list string temp equals new linked list string. This is not allowed because an array list is not a linked list. The same way that a cat is not a lion. A house cat is a feline. A lion is a feline. A lion is not a house cat, and a house cat is not a lion. Similarly, I cannot say list string equals new, or sorry, I can say that. I can't say linked list equals new list string. That would be because again, if linked list is a house cat, I cannot say any feline is a house cat. That may not be true. The given feline might be a tiger. I can't treat that like a house cat. So this is the substitution principle. It says I'm going to treat a subclass as though it were a parent class variable. Are there any questions about this? I cannot do this, and I also cannot do this. Sorry. Shouldn't have that open. That was not meant to be open there. So an example of this then is that if car has a function called isEngineLightOn, the class Jeep would inherit that. And so I could say JeepJ equals new Jeep, and because a Jeep is a car, and the car defines the function isEngineLightOn, then Jeep can use that engine light function. Jeep inherits that. The same way that car inherits the function start, or truck inherits the function brake, or bike inherits the field color. The child has everything the parent has. And I don't need to re-implement it. That's the key. So once again, just some vocabulary. If a new class is defined by adding on to an existing class, that is to say, when we do this, we're saying the new class is the subclass, and the existing class that's being added to is the superclass or parent. So we often call this a parent-child relationship. A subclass inherits from the superclass. It also extends from the superclass. This takes us to, if you ever see protected. Protected is kind of, it's not exactly halfway between public and private. It is similar. Does Java support multiple inheritance like C++? Thank God, no. Thank God, No, it does not. Because multiple inheritance just leads to just awful, awful, terrible, horrible problems. Java does support multiple interfaces, and we'll talk about how that's different from inheritance tomorrow. But no, it does not, thankfully. So, as expected, a subclass can access public fields and methods. The same as of the parent. So if a subclass can access its parent's public fields and methods. However, a subclass cannot access private fields and methods. So, like, for example, if your parents, say, had a safe in the house that they stored important documents in, and they didn't give you the code, you couldn't access that, even though you're their child. Protected means that you can treat a parent's fields or methods as though they were public. That is, if a method is protected, they are public from the perspective of child classes, but private from the perspective of other classes outside of the package, which gets into stuff I'm not going to worry about right now. So this is what we mean by inheritance. We may have something like the animal has a method called getName. Dog extends that, and it writes its own getName, and it says woof, and then super.getName. So if, like, say a dog's name were Rover, it would print woof, and then Rover. And it can use the super keyword to directly access the parent if the child overrides that method. So we'll get into an example of that in a second. But for the time being, we're going to take a 5-minute break. Here's what I want you to do in that 5-minute break. I want you to go on Colab. I want you to go to Resources. And I want you to take a minute and look at 2 files. I want you to look at clock and alarm clock. Clock, all this update code does... Oops, sorry, you're not seeing this. All this update code does in clock is it says, okay, go and get the local time from the computer and update the clock to match the local time. And then we have standard getters for hour, minute, second, setters for hour, minute, second. It has a 2-string brand name and get time. Protected, get time is string. And notice I just have this main method. I create a Casio clock. I print C, it gets the hour, etc. This is a clock. Then I want you to take time and I want you to look at this class alarm clock, which extends clock. And I want you to notice that alarm clock only has the fields alarm hour and alarm minute. That's all it has. Hang on. What about static? Static has nothing to do with public or private. A method can be public static or private static. It makes no difference. The static method doesn't have anything to do with visibility. A static method means it belongs to the class rather than any instance. So static has nothing to do with public or private. It's a different dimension. Like if you think of public, protected, private as on the x-axis, static and non-static is like a y-axis. It's just not related. Take a look at this. Notice that the alarm clock still uses fields like hour and minute. And I want you to think about where that hour and minute come from. So take the next 5 minutes. We'll come back at 24 past and look at the clock and alarm clock classes. And go ahead and put them into Eclipse and run them. And then we'll talk about it when we get back. Be right back. it's not 224 yet, but I will, I'll start as soon as it hits that. So this is alarm clock running. You can modify this alarm to be whatever time you want your alarm to be. And... Hi. I love you, Stuart, but you are being very bad. Sorry, my cat decided it was lecture. It was pet o'clock when it's actually lecture o'clock. Anyway. Alright, so I have this alarm clock class. From there, I can set, so right now it is 224, so if I set my alarm to 224, you'll notice that it then prints beep, 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 because the alarm has gone off. If I were to say 220, the alarm doesn't go off, because it's not time for the alarm to go off, so you can see the difference. This gets the current time from my computer, and then stores it into the clock. Now, to be clear, this functionality of getting the time, this is described by clock. Let's take a minute. Clock has hour, minute, second. It has a Boolean, is PM, true or false. Has a brand name. When I create a clock, I pass in a brand name. It calls this update function. The update function, this is just a glorified way of getting the current time. Don't worry too much about it. From there, I have get hour, get minute, get second, set hour, set minute, set second. I overloaded the constructor, so you should have read about overloaded methods. You can have two methods with the same name, provided their arguments are different. This one takes in not just the name, but also a time to set. And then I just have print the time as a string that prints hour, minute, second, which looks like this. It prints either AM or PM as well. So here I had 2:24 PM. So this is all the functionality I need for a clock. And when I run a clock, it is just a clock. It prints the time. It prints, I print get hour, so it prints 2 because it's currently 2 o'clock and some number of minutes and some number of seconds. So that's clock. Alarm clock, as you'll notice, extends clock. That means that alarm clock, the class, inherits all of these fields. It inherits brand name, hour, minute, second, and is PM. All 5 of them. It also inherits the update method, the get hour, get minute, get second, set hour, set minute, set second, toString, and get time is string. And when I say inherits, what I mean is none of these methods are... The only method that exists here is update, and it's because I changed it. Get hour, get minute, get second, I don't have anywhere in this code. Yet despite that, I can still say alarm clock.getHour. That's because the alarm clock is a child class of clock. Alarm clock is a clock, and so I can say get hour. The reason that relationship exists is because of this keyword up here, extends clock. This is how I tell Java alarm clock is a clock. So with alarm clock, when I construct it, in addition to a brand name, I also pass in alarm hour, alarm minute. Don't worry about this super keyword yet. We'll talk about the super keyword here in a minute. Similarly, from there, I override the parent's definition of update. That is, the parent has defined an update method, and all the update method does is get the current time and update all the variables to reflect that. My alarm clock, rather than just doing that, also has a function check alarm. So it still calls the parent update, and the way I call the parent update is super.update. Go to the super class and call its update function, but then check alarm, and if the alarm should go off, print beep, 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 beep. So this is why if I match the time to the current time, which is 2:28, and then I were to call update, it says beep, 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 beep as a result of that. And update is called in the constructor. Well, it's not called in the constructor. Sorry, it's not called in the constructor, but it is called when I update. Anyway, a toString, for instance, calls check alarm. Any questions so far? Any questions so far about the fact that I can say alarm clock.getHour even though there is no getHour function in alarm clock? That's because I'm calling the code in clock.java getHour. I'm calling this function. Now, I can also make a clock. Clock C equals new alarm clock. Can you repeat what super does? Super means go to the parent class and do something. In this case, go to the parent class and call the update method. It has a special purpose in the constructor. I haven't gotten there yet. Don't worry about it yet. You will have to worry about it later, but not for now. This just means go to the parent class and call the parent class update method. So whenever I call update on an alarm clock, it will go to the parent class update, and then it will call this check alarm function. Here. So the key is I can do both alarm clock equals new alarm clock 228, or I could do clock C equals new alarm clock. This is the substitution principle. And with both of these, I can print the clock. And you can see that it prints the clock Casio brand 228, Digitech brand 228. With both, I can do getHour because alarm clock can call the parent class's method. And a clock, of course, can call its own method, getHour. I can also do ac.getAlarmHour. ac.getAlarmHour. And that gets 2 because that's the alarm hour. The alarm hour for clock should be 12, but here's the thing. If I comment out this line, or uncomment this line of code doesn't compile. I cannot say c.getAlarmClock. This is because at runtime, C is an alarm clock. When I run my program, C will be an instance of the class alarm clock. But at compile time, which is separate from runtime, compile is when I hit compile, run is when I hit run. At compile time, C is not an alarm clock. That's because C is defined as a clock. As a result of this, at compile time, I can only call clock methods. And getAlarmHour is not a clock method. This method only exists in alarm clock. So I cannot call the method of a child class from the parent. For instance, if I had, say, a variable stored as a passenger vehicle, I could not say that passenger vehicle .saddle height. I can't do that because I would have to make the assumption that the passenger vehicle is a bike. And it may not be. The same way that a parallelogram may be a square, but it may not be. And so I can't call square functions on a parallelogram. That means a child can call the parent's methods, but a parent cannot call the child's method. It's a one-way relationship. You can go up from the child. You cannot automatically go down from the parent. But what you can do is a typecast. Notice this is typecasting C at compile time to an alarm clock. It is saying, for this line of code, treat C as though it were alarm clock, and then call getAlarmHour, which is inside of the alarm clock. This is a typecast. And if I do this, notice that it prints 12, which is the hour of my alarm, 12. So this works. But you have to be careful doing this, because the following can happen. Let's say instead of a clock or an alarm clock, I just made C a clock. It's no longer an alarm clock, it's just a clock, and that's it. Notice that this line of code where I typecast C to an alarm clock still compiles. But there's a problem. Because if I treat this like a clock, so now it is not just a clock at run, it's not just not an alarm clock at runtime, or at compile time, excuse me. This is to say this is a clock at runtime, not an alarm clock at runtime. It's also a clock at compile time. Java will compile the line of code that lets me try to typecast, because I can always try to go from the parent to the child with a typecast. But if it doesn't work, something bad happens. Namely, I get a class cast exception. And a class cast exception is when you try to convert one type to another when it's theoretically possible. That is, it's theoretically possible I can cast a clock to an alarm clock, but at runtime can't work. That is, I cannot make something initialized as a clock into an alarm clock. I can't do that. Again, though, if this were an alarm clock, then this is fine. So this is runtime polymorphism. It is treating one type as another type, specifically a child as a parent. But you cannot treat a parent as a child. I cannot say, for example, alarm clock C equals new clock Rolex. I don't think Rolex makes clocks. I think they just make watches. But nonetheless, you cannot say this. But you can say the parent equals the child. Any questions? So the advantage of doing this, why are we spending all this time and effort, is that now my alarm clock class is more concise. I have to write fewer methods, and that's because the methods are already defined in clock. Why rewrite all of these methods all over again? In fact, it would actually be a bad idea from a software design standpoint to do that. So let's now go back to our triangle class. Let's go back to talking about our triangle class. Right now, without polymorphism, I have a right triangle class and an equilateral triangle class. I don't actually have an angle field, but we could add that. Let's say I wanted to get the angles of right triangle and equilateral triangle. I could calculate that. But from there, I have a perimeter method that is identical in both classes. Notice that equilateral triangle, what is the perimeter? A plus B plus C. Right triangle, what is the perimeter? A plus B plus C. So for the what you wrote, Tianyu, for what you wrote, it's two different answers. So again, at runtime, this is an alarm clock. When running, it is an alarm clock because it is stored as an alarm clock. But at compile time, when you are compiling your code, this is a clock. So it depends on your perspective. The variable is a clock, such as it relates to compiling. But the memory address at runtime stores an alarm clock object. This is why at runtime I can convert C to an alarm clock, and compile time it will let me try, and at runtime it will succeed. But I can't do system.out.println c.getAlarm because at compile time, this is not an alarm clock, it's a clock. And clocks do not have get alarm hour. So it's not as simple as it's this. It depends on whether you're talking about at compile time or at runtime. Notice that equilateral triangle and right triangle both define a function area, but they're implemented differently, but they have identical implementations of toString. The problem with this approach is that this approach is not very dry. Both triangles have a lot of overlapping information, a lot of information that could just be copied and pasted. The three sides, the perimeter, the toString, etc. So instead, what we want to do is we want to define a parent class, triangle, where we put the three side variables. We define that a method area should exist, though it's not implemented in the parent. Each child implements their own area. We define methods for perimeter and toString and implement them because the implementations between the two are the same. Right triangle that extends triangle and equilateral triangle that extends triangle. So I'm going to create one class to merge the things these two have in common, but still let right triangle and equilateral triangle be different. The goal is we want to be dry, don't repeat yourself, as opposed to wet, write everything twice. And that's because wet is bad. Dry is better than wet. So how do we do this? Well, we start by creating a new class to serve as the parent class. This class is going to be triangle. And triangle is going to have protected double, side A, side B, and side C. It will then have a constructor, public triangle, double side A, double side B, and double side C. And these are simply passed through. This dot side A equals side A. This dot side B equals side B. This dot side C equals side C. From there, we can define public double perimeter, which is simply going to be return side A plus side B plus side C. I'm then going to say that triangles need to have a means to define area. So for now, I'm going to say public double area, but I'm going to make this a stub. We'll talk about why later. Return 0.0. And then finally, public string toString. I'm simply going to use the same toString that I used in equilateral triangle and right triangle. So I'm going to define this class as the parent class triangle. From there, I can then say equilateral triangle extends triangle. From there, I no longer need to define the side A, B, and C because they're defined in the parent class triangle. They're defined here, so equilateral triangle doesn't need to define them at all. We'll get into this red underline in a second. Stay tuned for that. I also don't need to bother defining perimeter anymore because the parent class defines perimeter exactly the same way. What does a child do when it doesn't know the answer to the question? It just goes to its parent, right? So, delete that. I don't need it anymore. It's defined in the parent. Similarly, toString. I don't need it anymore. It's defined in the parent. However, the area function, I'm actually overriding the parent. The equilateral triangle is in its rebellious teenage years, and it's saying, I don't need mom and dad to tell me how to calculate my area. I'm going to calculate it myself. Well, it only has one parent, so I don't need MAD or, well, I don't want to say the other one. I don't need mom/dad to tell me this. Anyway. From there, right triangle, same thing. The parent defines perimeter, so we're going to say extends triangle. The parent defines perimeter. We don't need it anymore. The parent defines the three sides. We don't need it anymore. The parent defines toString. We don't need it anymore. But we are still defining our own area, right? So now, there's one other thing I need to do. And I'm going to just type it first, and I'll explain it later. So don't worry if you don't get this yet. Because I'm going to show some things first, and then I'll explain what I'm typing here in the constructor. Similarly, super, side A, side B, and then all right. I'll explain what this is later. Oh, I need an extra parenthesis there. There we go. So now I'm going to make a demo class. New class triangle demo. And I have public static void main string args. I can do the following now. I can say public, or actually no, not public, excuse me, triangle T equals new right triangle. And I can say the sides are 3, 4. This gives me a 3, 4, 5 right triangle. I can also say triangle E equals new equilateral triangle 3, which is a 3, 3, 3 equilateral triangle. Notice that now I can treat E and T as the same type. This has the following use. List triangle L equals new array list. Just need to import these two. And then L.add T and L.add E. I have now added both of these triangles to the same list. And I can do things like for triangle, I'm going to just call this R in L, system.out.println R.perimeter. Oops. And if I run this program, I get the perimeter 12, which is the sum of 3, 4, and 5, and 9, which is the sum of 3, 3, and 3. So notice now I can treat these two things like the same type, and it lets me put different types into the same list. It lets me put different types into the same list. Because the list is defined not by the individual types, but by the parent type. But now, there is something else I can do. I can do this. Triangle wrong is going to be the variable name, equals new triangle 1, 2, 4. This is mathematically not possible. You cannot make a triangle with the sides 1, 2, and 4. It cannot be done. So how do I prevent people from doing this? How do I prevent someone? Well, what I could say is, if you want to instantiate a triangle, you cannot make a triangle. Instead, you can only make right triangles and equilateral triangles. I'm going to add that limitation. And the way I do that is I go to my class triangle and I define this as public abstract class triangle. And an abstract class is one that cannot be directly instantiated. So when I come over here now, this line of code doesn't even compile anymore. I'm preventing someone from directly creating a triangle. They can still indirectly create a triangle. They can make a right triangle or an equilateral triangle, but they cannot directly create a triangle. Any questions about this so far? So this line of code won't compile. I'm not allowed to say new triangle anymore because it's abstract. There's an advantage to having an abstract class. An abstract class can define methods as abstract. Namely, abstract double area. This defines the area method as being abstract at the parent level. What this means is the parent is not going to implement area. However, the children have to implement it. You could think of it like the parent giving a child chores. The parent is saying, hey, if you extend me, that's your problem. I'm passing the buck. I'm not dealing with it. You figure it out. Right triangle then defines area this way. Equilateral triangle defines it this way. Because these classes extend triangle, they are required to implement area, such that if I delete the area method, this class no longer compiles. The reason it doesn't compile, the type equilateral triangle must implement the inherited abstract method triangle.area. I am required to define the triangle area, which I do by re-adding the area method. So you have to do it. It's a chore the parent gives you. You don't have to define any of the non-abstract methods. But if you want to, you're welcome to override them. For example, I can say, in right triangle, public string to string, return right space plus super dot toString. This, remember, means go to the parent toString function. The parent toString function says triangle with sides A, B, C. And I'm just going to add right to the front of it. So instead of saying triangle with sides 3, 4, 5, it says right triangle with sides 3, 4, 5. Similarly, with equilateral, I could simply replace the entire toString method if I want. I don't even need to call super. I can just say equilateral triangle with all sides equal to plus side A. I don't have to reference super. Also notice I don't need to say super side A. Even though I could say super.side A. But the super is implied because there is no side A variable in the child. It will automatically look to the parent. Again, what do you do if the child doesn't know an answer to a question? It asks the parent. So when I say in the triangle, or when I say in triangle demo, if I say for this right triangle, give me the perimeter, well, the right triangle class doesn't know what the perimeter is. It doesn't have a perimeter function. So what does it do? It goes and asks the parent. The parent class does know what the perimeter is, and the parent answers the question. Equilateral triangle doesn't know what side A is. So what does it do? It goes to the parent, and the parent knows what side A is. And the child can see side A because it's protected, which means it is effectively public to the children. From there, if I were to go through and in Triangle Demo, instead of printing the perimeter, I did system.out.println R, just print the triangle itself. You'll see that I get right triangle with sides 3, 4, 5, equilateral triangle with all sides equal to 3. And again, I have a version of this code that's better documented already uploaded, so you don't need to furiously copy it down. You can download these. But are there... So for now, I've already said I'm going to explain this and this in a second. I'm going to explain what that is, but not counting the things I just highlighted. Everything else. So this code, all of Triangle, and Triangle Demo. Are there any questions? Are there any questions so far? Hopefully my cat won't knock my camera over again. Off center again. All right. So now, let's go to the whiteboard and let's diagram what this looks like, what this relationship looks like. Let's say that I create just this up a bit. If I create a right triangle object, this is a right triangle object. The right triangle, as I have written it, has no fields at all. It has no fields. If you look at the class, and I'll pull it up here, right triangle doesn't have any of its own fields. I just remembered green is a terrible color for my whiteboard. So this is the class right triangle. And typically you put the fields right below the class name, but there are none. It does, however, have a method area and a method toString. The right triangle by itself has no fields. It doesn't have a perimeter function. But what it does have is it has this access called super. And super points to an instance of triangle. The parent, in some ways, is like a separate class, only these are inexorably linked, parent and child. The parent has fields side A, side B, and side C. The parent has perimeter. It has toString, and it has an abstract area. So if right triangle needs to find out what side A is for the purpose of calculating area, it needs to follow super to the parent class. This means that right triangle, when it's created, it must also create its parent. That is to say, the right triangle cannot exist by itself. It is impossible for the right triangle to survive on its own. It needs a parent. And so when we create a right triangle, when we create that, the right triangle class in turn needs to create its parent in order for it to have one. The right triangle class creates the parent. So, whenever we call the constructor of right triangle, where is it? Whenever we call the constructor of right triangle, and let's actually for now start with equilateral triangle because it's easier to explain. Equilateral triangle needs to create a parent triangle instance. And that's what this line of code does. It calls the constructor of triangle that takes inside A, B, and C. And remember, it just passes these through. Now, because this is an equilateral triangle and all sides are the same, side A equals side length, side B equals side length, and side C equals side length. So I just call super. Super means go to the parent. Super with a parenthesis, not with a dot, just with parentheses means go to the constructor of the parent class that takes in 3 doubles and create the parent with this input. So this calls this constructor. And this creates the variables side A, B, and C. That's the first thing a child has to do. A child must create its parent. It just has to be done. In fact, it's so important that the child creates the parent that you can literally not do anything before super. That is, create the instance of the parent. I'm not even allowed to do system.out.println hi mom. She's not watching, by the way, but if she were, she'd probably be, I don't know, mediocre about it probably. Anyway, point being, I'm not even allowed to do this. Notice I'm getting red underlines of shame. This doesn't compile because I do anything before super. If I want to print after I call super, sure, that's fine. I'm allowed to do that later, but I can't do it before super. So in a child class, the first thing that you have to do is create the parent. Now with right triangle, that presents a problem because it means we can't even do something like this. Double side C equals that. Even though we need the side C, we cannot do it this way. We're not allowed to. I can do it one of 2 ways. I can first just copy and paste, and instead of side C, I actually use the value, and then I delete this line. That's an option. The other option is I could define this as a separate function, but it must be static. It doesn't matter if it's public or private, but let's do private static calculate hypotenuse. I'm probably still spelling it wrong. I don't know how to spell this word. Anyway, can anyone spell check that for me? Anyway, calculate hypotenuse, double side A, side B. I can then paste that code. Okay, there is no. For some reason, I was assured there was an E there, but I guess I was wrong. Anyway. And then I can say return that, but notice this function is static. The reason it's static is because there is no this instance. Oh, and I need to say private static double. And then I can say calculate hypotenuse. I can also do this. If the method is not static, this code won't compile. And that's because, remember, a static method is called without a calling instance. And we can't have a calling instance because at the point we're creating this, before we call super, before the call to super goes, what we actually have is we have this. And this right triangle doesn't actually exist yet. We're still creating it. So it's more like ... We cannot create this right triangle until first we create the parent triangle instance. And then the parent triangle instance is connected to the child by this super keyword. After we create the parent, then right triangle can exist. And so if the instance doesn't exist yet at the time before we call super, then we cannot call a non-static method because a non-static method requires a calling instance, which again, we don't have yet. Are there any questions about this? So the idea of this polymorphism is used to make our code more dry. Not dry in terms of my sense of humor, yuck, 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 but dry in terms of don't repeat yourself. We don't want the same code in two different places. Here's why. If we have, hypothetically, the same code in two different places, copy and paste it. We have two different classes that have the same feature or set of features. And these two things are the same in both places. Let's say that as we're maintaining our software, because we've talked a lot about the importance of maintenance, let's say that this requires that you delete this line of code and replace it with two others. If this same code is in two different places, you have to do this twice. If it's in one place, one shared place, higher up in the hierarchy, you only have to change it once, because this behavior is inherited. Here's why this is important. Let's say a change later on requires you add a line of code here. You add a line of code here and you think, I'm done. Well, now you have a bug. Because one of the two places that does the feature, you've changed it, but not in the other. So now the same feature will work for this set of classes, but not this one. So this is why we export that to a single place. This is why it's important to be dry. Don't repeat yourself, as opposed to wet. Write everything twice. So I know I've emphasized dry, don't repeat yourself multiple times, and that may seem ironic, but that hopefully just makes you remember it all the more. Now, let's go back to the slides. So this is what we've effectively done. You can extend any class, abstract and normal. The only difference between an abstract class and a normal class, an abstract class cannot be directly instantiated. So for example, list is an abstract class. I cannot, for example, say list integer numbers equals new list integer. I'm not allowed to do this. And the reason is list is abstract. It cannot be directly instantiated. Just like I couldn't directly instantiate triangle triangle S equals new triangle 3, 4, 5. Because triangle is abstract, I'm not allowed to call the constructor. So list is abstract, but I can do list is new array list, and that's fine. Because this is concrete. I'm storing the concrete variable, or the concrete value, into a variable that is the abstract type, but that's fine. That's just the substitution principle at work. The polymorphism is the ability to reference is the ability of a reference variable to change the behavior it has according to the type of the object instance it's holding. For example, a triangle that's holding a right triangle calculates its area differently from a triangle that's holding an equilateral triangle. And at runtime, the way I will calculate that area, let's do system.println r.area, changes. So to that end, when I run this code, sorry, I forgot to delete that line of code. When I run this, I forgot to fix this bug too. Sorry, this is why when I make changes on the fly, sometimes I need to be reminded to undo them. All right. So the right triangle's area, when I calculate T, which is a right triangle, when I say this triangle's area, it goes to the class right triangle and runs this area function. But when I go to E and I calculate the area, it doesn't go to right triangle, it goes to equilateral triangle. So it changes which function is called, which area is called, based on how the type, not the variable type, but the instantiation type. Because both of these triangles are type triangle. But this is instantiated as a right triangle, and this one's instantiated as equilateral. So when I say t.area means go to right triangle.java and run area on T. And when I say e.area, go to equilateral triangle and run area on E. So this calls two different functions. The first time through the loop, it calls right triangle because T is a right triangle. The second time it calls equilateral triangle because E is an equilateral triangle. That's runtime polymorphism. And again, I have this example described here. So let's say I had two Jaguars. I had a light morph Jaguar as L Jaguar and a dark morph Jaguar as D Jaguar. Both of them define a method that is described in the parent Jaguar as getColor. This one returns, I am the light morph one, I am the melanistic one. If I create two Jaguars, J1 light Jaguar, J2 dark Jaguar, and I print .getColor on J2, it's going to know to call the dark Jaguar's getColor. It's not going to get confused because it was instantiated as a dark morph Jaguar. It also lets you do things like this, because as we've talked about, technically every class we have written has an implicit extends object. All of them. It's implicit because you don't have to write it. It's implied. If you don't extend any other class, it extends object. So that means that ultimately every class extends object. If not directly, then indirectly. Because clock extends object and alarm clock extends clock, remember that means clock is an object and alarm clock is an object. By the transitive property, that means alarm clock is an object. But we don't need to write that because Java does that implicitly. But as a result of this, we can store any data type into this field object. And then if we want to, we can just typecast it to whatever we stored it as later if we need to do those functions or extract that information. So again, why do this? Limit code repetition. Add features to existing code without modifying the existing class. It actually, while this seems complicated, it actually improves the simplicity of working with objects because you can treat multiple different types as a single type when it's convenient to do so. Types of polymorphism, these are the things that a child class can do. It can override a method, that is, you know, screw you, mom, I'm not doing the method your way, I'm going to do the method my own way, like we did with the alarm clock update method. It can override abstract method. This is the mom giving the child chores. So triangle gave right and equilateral triangle the chore of writing area. So that is overriding an abstract method. And then we'll talk about interfaces tomorrow because we're at almost at 15 minutes past the hour. So the in-class activity today. Is you're going to and you're welcome, you're welcome as always to work in a group in Discord. Just remember, everyone needs to submit independently. From there, you're going to download the attached zip file, Animal Goes to the Vet. And you need to add to this file, finish the give shot method in the vet class, which accepts an argument of a type animal, and it prints the correct output for each animal when get shot is invoked. So, for example, dog Jack after the shot cried woof. Cat Garfield after the shot cried meow. Animal Marlowe after the shot cried ... something like that. It will make sense when you look at the code. And certainly I can help in office hours, which will start in 15 minutes. But this is the assignment. So wrapping up lecture for today, I will see everyone tomorrow. As usual, I can stick around for about 3 minutes for questions. But then I have office hours starting at 3:30. So I'll have to cut it off there. But that is otherwise the end of lecture. Take care.